Good day, everyone, and welcome to the Matplotlib tutorial. Right, the purpose of this tutorial is to introduce you to the core plotting functions and methods in the Matplotlib library, and you'll be required to do more reading to learn more about other methods and functions that are available to you in the Matplotlib Python library. So we have to import matplotlib.pyplot as PLT, and we also import numpy because we'll be using it in this tutorial. And we have the magic command, which is a percentage sign and then matplotlib line. So this line over here will help or make it possible to see the visualizations in Jupyter Notebook. Okay, so take note of that. And then in Matplotlib, we can configure the graph format to a number of inline.backend format to give your graph different look and feel as preferred. Okay, examples of those are SVG and Retina. Right, so this is just sort of like display or the quality or the resolution of your graphs. Okay, so we have a number of them, and then for this tutorial we will set it to Retina. Okay, so I help us get a good or a better resolution for our graphs. That's all. And then additionally, Matplotlib comes with an array of plotting styles which you can choose from. Okay, so for the purpose of this tutorial, we're going to use Seaborn. So Seaborn is also a plotting style. We know Seaborn is also another Python library for plotting and all that. But in this case, Seaborn here in this context is a plotting style, right, in Matplotlib, and so that is what we're going to use. Okay, so to make a plot, all you need is to call the plot function, and then it takes in a list like object, okay, an array. And so we have a list with this list, and then plt.plot a list, and then you have this, right? In the event that the list is only one, then on the x-axis it will use the index of the list items. Okay, so 4 is at index 0, so on index 0 you plot 4. Index 1 is 2, right? 1 you have 2, and index 3, index 0 1 to index 2 is 9, so at index 2 you have 9. Okay, so it uses the index of the items as the x values, and then the items themselves as the y values. In the event that you have two lists, then the first one will be used as the x values, and then the second list will be used as the y values, and then you have this. Okay, and you can also, so Matplotlib automatically sets the x limits and then the y limits, all right, based on the inputs. Okay, so here we have the x limits, the x range is from 3 to 9, and then that of y is from 23 to 88. Okay, so it automatically sets it. Now you can manually set the limit as well. Okay, so in this case we set the limits of the x from 0 to 10. Okay, the range from 0 to 10, and then for the y 15 to 100. Okay, so that is that. You can just use the xlim function, then the ylim function, which takes in the lower range of the x and the upper range of the x, and for the y to lower range of the y and the upper range of the y as well. Okay, so the plot function also comes with a number of arguments, right? And you can always play around with them as and when you prefer. Okay, so next we're going to play around with some of the parameters in the plot function and some additional methods. Okay, so we'll use the numpy's linspace function to create an array x containing 100 float from -5 to 5. Okay, and then we're going to make a quadratic function from that. And one of the parameters that we're going to use is the color, right? The color argument or parameter, and you can set it to different colors as preferred, right? And then when you click here, you would have access to more colors, right? A list of all available colors in Matplotlib. So we create our x, which is, values from between -5 and 5,000 values actually. And then the y is, x squared. And then we plot that and we set the color to blue, and this is what we have. Okay, that's what we have. So the plt dot show, let's show what that does. Okay, so when you don't include the plt dot show, you're gonna have this line over here, right? It really doesn't mean anything for us. It's just saying the location in the memory where this thing is stored. Okay, so it's not necessary, we don't need it. So let's just use our plt.show to get rid of it, right? And then that's it. um Let me start running from the beginning, just so I have that beautiful seaborn feel. Great. Okay, so let's add, some text to the plot to give some more information, right? So plt.title allows you to, write a title for your plot. And then we have the x label, which is used to label your x-axis, and then the y label, which is used to label your y-axis, right? So you need to take note of these methods as well. And then let's come to line and style color. Okay, so by default, Matplotlib draws a line to join 2 points in the graph. You may manually specify the line style of your choice. You may also add some colors to the the line styles as well. Okay, so you can click on this link to read more about that. Okay, so in this graph below, we're going to use G dash dash, which means that a green dashed line style. Okay, and you can always play around with different styles to know which ones are available. Okay, so in the plot function, we have our X, we have our Y, and then you have the line style. Okay, so you're saying we want green, but green dashed line. Okay, so when you run this, you have this. If you make the dash, if you clear one dash, this is what you have. Okay, let's add a dot. This is what you have. Okay, so you can always play around with it. um, yeah, and so this one too also has a title, x label, and y label. Okay, and then the plt.show. Okay, so you can also plot multiple lines on the same graph. You can use the plot function a number of times before calling the show. Okay, so here we have three plots. One is a cubic function, and then this one is raised to the power, the y is raised to the power 4, and then um, the y itself, right, which is x squared. So the y here is representing x squared, and then you have x cubed and x raised to the power 4. Okay, and you have all the plots on the same graph, so it's possible to do that. And then as usual, you have your title, your x label, and your y label. You're good to go. Okay, we have bar plot, and we know bar plot is used to plot categorical values. Okay, it takes in the categorical values as x and its corresponding y values and height. Okay, so in this case, we have course names: Eshete, Nagaka, Mwango, Mansa, and Kofi, which are categorical values, and then you have their respective scores, right? And so when we call the bar function with course names and scores, this is what we have. Okay, and then as usual, title, x label, y label. Okay, very simple. Just give it the categorical, um, values, and then the height or the y value, and then you're good to go. Okay. The good thing is you can also compare, multiple categorical values over, larger x values or larger categorical values. So in this case, we have four classes in a university. We have the freshmen, we have the sophomores, you have the juniors, you have the seniors. Okay, and we want to compare the performance of girls and boys, or males and females, across these classes. Okay, So you can also do that. So we have the male scores over here, we have the female scores, and then we have the indices or the index to be np.arrange. So it creates a numpy array from 0 to 3, and it will be used on the x-axis. Okay, and then the width, which is used to specify the width of the bar, is 0.4. Okay, now we have plt.xticks, right? So the xticks, um, what it does, so we have the indices plus the width divided by 2, so which means that we want the labels to be in the middle, right? That is why we have divided by 2. We want it to be in the middle. Okay, and then these are the labels: freshmen, sophomores, juniors, and seniors. Okay, so there, if you want it to be in the middle, it's just the indices plus the width divided by 2. Okay, and then we do the plotting. So indices, male scores, then the width plus, and then you have the label, which is males, right? Which is what we have here. Okay, the labels. And then if you want to plot the second bar, it's indices plus the width, right? So that it comes together. Okay. Um, and then female scores, the width, and then the label as females, and then you do your title, your X label, your Y label, and the legend, plt.legend, just brings this onto the bar, right? It's more or less like, what is the meaning of the blue color and then the green color, right? That is a legend. It also takes in some parameters, so you can also go and check that as well. But what it does is that it automatically finds an appropriate place on the graph to place what you have here. Okay, so you can manually specify which parts you want to see it. So either here, 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 or here. But if you don't specify anything, Matplotlib will automatically find a good place and then place the legend. Okay, so now let's get to histogram, right? So to plot a histogram, what I did was I generated 200 random numbers between 150 and 200, and that is what I stored in these x values 1, x values 2, and x values 3, right? So I said for I in range 200, random dot rand int, right? So it generates random numbers between a random number between 150 and 200, and do it 200 times, right? For the x2 values, whatever number is generated, I added 25 to it. For x value 3, what number is generated, I added 75 to it, and then you append. Okay, so if you want to plot a histogram, just call the plt.hist function, you put in your x values, and then you may also specify the number of bins you want to see. You can also play around with that. um, and then the title, X label, Y label, and that's it. Very simple. And you can, so just like the bar, you can also plot um, two or more histogram on the same graph. Okay, so I have my x values 1, x values 2, and x values 3, um, with a bin and a label. So there are hist type as well. There's a step field, and then there is the bar. The default one is the bar. Okay, so you can also play around with that and find more hist types. Okay, um, so what is the use of plotting multiple things on the same graph, right? It helps to do a lot of comparison, right? It helps to do some comparison right on the same graph. So take note of that. And then we have the box plot, right? So you can plot a box plot using the box plot function, right? And there are a lot of other parameters to be explored. So you need to do your research and learn more about other parameters. So plt.boxplot, you just put in your x values and you're good to go. Very simple. Right? If you want to play around it too, there are additional parameters or arguments that you can play around with. And then we go to scatter plot, right? We all know what a scatter plot does, right? plt.scatter, you have your x value, so it takes in um, two list like objects, right? And all you have to do is just call plt.scatter with your two list-like objects, and you're good to go. Title plt.show, and you're fine, right? One thing you can do is you can use the s argument, right, to plot different sizes of the scatter point, right? So when you look at the scatter point, you realize that some are small, some are medium size, some are also big sizes, okay? So the scale allows you to do that, right? So I just generated 200 random integers, right? And then I multiplied each of them by 100. I raised the power of each of them to 2 and multiplied by 100, okay? And then I call the plt.scatter function, provided my x values, and I set the s to scale, right? And then it produced this. Okay, so it's very, very important. Um, and you can also color your point, right? You can also color your point. This is very useful when you really want to see where, so for example, let's say you want to plot the relationship between students, right? Student performance or student grades and something else, right? But then in the student grades, you want to see, the relationship for the two genders, right? Male and female, right? So coloring, your scatter plot can really help you to see, oh, how are males doing? How is the relationship affecting males? How is it affecting females? Right. So that is one possible use case for coloring your scatter point. And then we come to text and annotations. Right. So all you have to do is just use the text function to do that. Okay. So we created, some x values between between -2 and 2, so 500 x values, and then our y is x squared, right? So we created a variable px equal to 0, 9, right? And what it means is the x coordinate of the position we want to place our text, and then py is px raised to the power 2, that's the y coordinate of the position we want to place our text. Okay, so we plot, right? So we are saying xy. This r here means red, and the dash is, um, just a straight line, like we don't want any breaks. Okay, so it plots, so you have this smooth line going from the side right to the side. Okay, and we want the color red, and then the px and py will just produce a dot, right? And that dot, the bo we have here is we want a rounded dot with the color blue, right? So we can change it to J, right? You can change it to J, and you have green dot. Okay, so you can always play around with that, right? So you can, go to the documentation and check for the different colors and what letters are used to represent them. Okay, so the px and py indicates where we want to put the dots, right? So this is a dot we have over here. And then the plt.text, right? So the first two arguments are the position of the y, of the x and y coordinates, okay? And then the next argument is the text itself. So we are saying quadratic function, and then we call this next line character. We are saying y is equal to x squared, right? So the dollar sign, tells it that this is a mathematical function, right? And so you should treat it as such. And the next argument is the font size, so you can set the font size to whatever size you want. You can also play around with it, You can play around with it, however you like it, right? And we set the color to green, then the horizontal alignment to center, okay? And then we also have text, another text, which is px plus px plus 0.09. So this one you can play around with it because it just helps you to position the text very well, right? So you can play around with it. Okay, and then the text is x is equal to, to two floating points, and then y, so next line character, and then y is equal to, so essentially you're trying to say that x is equal to px, x is equal to px, and then y is equal to py, right? But then we want them in two floating points. That's all it means. And then you can also set the rotation to 50 degrees, the color to gray, so you can play around with the rotation. You can also play around with the color as well. Okay, so you also have subplot. Okay, subplot allows us to, plot a number, to have multiple plots on a grid. Okay, so when you call the subplot function, it takes in the number of rows, the number of columns, and then the third argument is the position in the grid that you want to make a particular plot. Okay, so this is one. So in this case, we are trying to say that we want 2 rows, 2 columns. Okay, so if you have 2 rows, if you have 2, and the next argument is 1, it means you want to plot here. If it's 2, you want to plot it here. If it's 3, you want to plot it here. If it's 4, you want to plot it here. Okay, so it is always from the left to the right, left to the right. So top left to top right, then bottom left to bottom right. That's how it works. All right, so what I'm doing here is, so I've created my x values, which is from -10 to 10, which is 1,000 values between -10 to 10. And then I'm just, what I'm doing is plt.subplot, right? I have my I mean 2 rows and 2 columns, and then I plus 1. Remember, I starts from 0. So what I'm trying to say is 1, right? So in this case, 1. And then plt.plot, right? So x, so the x represent my x values, and the y is, x raised to the power, so in this case, if it's running for the first time, it will be 0, right? So it will be 1, right? Which will give me a straight line. So in the second iteration, this place will be 2, and this one also will be 2, and it will give me this. In the third iteration, this one will be 3, and this will also be 3, and it will give me this. In the fourth iteration, this will be 4, and this will be 4, and I'll have this. Okay, so that's how you use a subplot. And then we have saving a plot, right? So you can also save your plots to be used for other purposes, as in when you wish or prefer, right? So all you have to do is use the savefig method or function, and that's it. So all you have to do is call the savefig function, and then it takes in the name of the plot, right? However you want to name it, and then you just add the extension to it, and then you're good to go. You can set a transparent to true. So if you set a transparent to true, then it means that you're not going to have these grid lines, right? You're not going to have these grid lines. If you don't set the transparent, then it means you're going to have these grid lines, right? And then my references, these are my references. These are the websites that I got some of my content from. So you can visit the website to learn more. As part of the tutorial, we have a task that you can that I have provided um, to help you practice more, um, about Matplotlib. Okay, to take your Matplotlib, ninja skills to the next level. Okay, so do the task. If you have any challenges, if you encounter any challenges, please feel free to reach out to me, and I'll be very, very, very happy to help you. Okay, so this brings us to the end of the Matplotlib tutorial, and have a good one until we meet in the next tutorial. Thank you.